Okay, this lesson is on multiplying and dividing rational expressions, and these are basically going to follow the rules of multiplying and dividing fractions. So when I multiply fractions, you multiply the tops together and you multiply the bottoms together. 3 times 2 is 6. 5 times 7 is 35. Okay? There is my, as I multiply my fractions. Multiply the numerators together, multiply the denominators together. When it comes to dividing, I have one additional step I need to do. I actually flip my second fraction. So it's 1 over 2, it's going to become 2 over 1. And then it turns to multiplying. So I have my 4 over 9 times 2 over 1. I flip my second fraction and it turns to multiplying. Then I can multiply the tops together, multiply the bottoms together. Numerators will give me 8 when multiplied, denominators will give me 9 when multiplied. Okay? Now, how does this go into rational expressions? Well, the first thing I should do is see if there's anything I can do to factor. Is there anything I can do to factor these larger rational expressions? On the first fraction, I have 5x in the numerator, and I have difference of squares on the denominator. X plus 3, x minus 3. Multiplied by. Then I have a perfect square trinomial. Also can be considered a simple trinomial. Multiplies the 9, adds the 6, will be 3 and 3. X plus 3, x plus 3. The denominator is common factoring. I can take out a 5x, and I'm left with 2x plus 1 in the denominator. Now when it comes to multiplying these together, I can simply just all write them as one as one continuous line. So I have 5x times x plus 3 times x plus 3, all divided by x plus 3, x minus 3, then take the other fraction, 5x, 2x plus 1. I can multiply them all together because brackets means multiplying, and so does the times symbol mean multiplying. So I really just have it multiplying, multiplying, multiplying all together. Then I can look and see, is there anything I can reduce or cancel out? Well, on both the top and the bottom, they have a 5x, so I can cancel that out. They both also have x plus 3's. I can cancel them out. So that will leave me with 1x plus 3 over x minus 3 and 2x plus 1. Well, the next step then is to state any restrictions. Anything that's going to make my denominator go to 0. The first part of the brackets here, x minus 3. Well, if x equaled positive 3, that wouldn't work. That would make the denominator go to 0. The second set of brackets, 2x plus 1. Well, if x equaled negative 1/2, that would make the denominator go to 0. So I've multiplied, I factored, then I multiplied them all together, and then I reduced and stated my restrictions. For dividing, there's just one additional step again to do. Oh, actually, I should say before I move on that you state restrictions not just on the answer, but maybe back to the factored form. Are there anything else, any other of these factors that would make go to 0? So I did x minus 3 already. Well, what about x plus 3? Oh, so that means negative 3 would not work. And then the 5x was a factor. So what would make the 5x go to 0? Well, if x equaled 0. So I actually have 4 restrictions for this question. Don't just look at the answer. Look back at the factored form of the question. When it comes to dividing, you have a first step where you need to flip the second fraction. Okay, so I have 9 over 4x, and the second times the second fraction flipped, 3x over 27x minus 18. Okay, so I flip the second fraction, turn it to multiplying. Then I can see if I can factor anything. Okay, I can factor the denominator on the second fraction. So 9 over 4x times 3x over 9. This is common factoring. 3x minus 2. Okay, then I can multiply them all together. So I will have 9 times 3x is 27x over 4x times 9 times 3x minus 2. Again, when you're multiplying, you just kind of put them all together. These two together is 27x. 9 times 3x is 27x. Then I had 4x and a 9 and 3x minus 2. At this point, it might be a good idea to check for any restrictions. So I had 4x. Well, what won't work? x cannot equal 0. The 9, there's no variable on it, so I don't need to worry about it. Then I did 3x minus 2. Oh, I cannot have x equaling 2/3. Okay? Then I have to see if there's anything else that would potentially happen. Well, back in the question, I had the 3x on the denominator, so maybe I should look at that, because if the denominator is 0 at any point, it doesn't have to be just at the final answer, at any point, then it technically wouldn't exist. So I have a 3x here in the denominator, you need to check it. Oh, 3 times, I already had 0, so I'm safe. I already had the 0 as a restriction. Okay, but you just do need to check to see if there's any other ones you need to add on there. And then you can just do a little bit of simplification on the bottom. So I would have, well, my x's would cancel, so I'd be just left with 27 over 36 times 3x minus 2. And you have your restrictions again. X cannot equal 0 or 2/3. Okay? And then you might want to distribute the 36 in if you so need it. So multiplying fractions, or multiplying rational expressions, factor first. Then you can multiply them all together, bringing all your tops together, bringing all your bottoms together, and state your restrictions. For dividing, flip the second fraction. Okay? Again, see if you can factor. Bring them all together. You can divide, you bring them all together by multiplying. So it's flip the second fraction, multiply. You check for any restrictions, and you reduce what you can. Okay? Actually, the 27 over 36 can be reduced down a little bit further if I divide both by 9. And so that will leave me with 3 over 4 times 3x minus 2. And I can again make that 3 over 12x minus 8 if I multiplied the 4 in. Okay? So you can check to see if you can reduce those rational expressions any further. All right, short little lesson on multiplying and dividing rational expressions. Thank you very much.